one of the things that we've noticed so far is that if the derivative of a function is positive, that means at some x value a, that means that the function itself is increasing at that x value. If the derivative of a function is negative at some x value, then the original function is decreasing at that x value. And if the derivative is 0, then we can't actually tell if it's increasing or decreasing or neither. So just to give you an example of where the derivative is 0 and why you can't tell is if you're at a local maximum, well, the derivative there is 0, but it's increasing to the left and decreasing to the right. Or, if we're at a spot at a level spot like this, well, this function is increasing the whole time, even though the derivative at this point is 0. Or, you could have a function that's decreasing the whole time at a spot where the derivative is 0. So if the derivative is 0, you actually can't tell if the function is increasing or decreasing, or, like this one here, maybe it's not increasing or decreasing, rather it's a mix, depending on which way you go. But if the derivative of the function is positive or negative, that gives you some definite information about which way the function is headed. As an example, just based on the graph of e sine x and its derivative, which happens to be cosine x times e to the sine x, let's just check that this general trend that we've noticed does work for this graph. So where is this function increasing? Well, it looks like it's increasing from about here to there. And again, from here to there. This function is periodic since sine of x is periodic. So in actual fact, the function just repeats itself out here if we go further to the right and further to the left. All right, so on these spots where f is increasing, we expect its derivative to be positive. So let's look at the corresponding x values on the graph of the derivative of f. So sure enough, for these x values where the original function was increasing, the derivative is positive. That is, it's above the x-axis. And same here. Okay, well, what about decreasing? The original function f is decreasing here, and again, there's everything that we see in this graph is repeated off to the left because of the periodicity of this function, and it's also decreasing on this interval here. And if we look at the corresponding x values down on the graph of the derivative, sure enough, the value of the derivative is negative on this interval where the original function was decreasing, and same thing over here. The original function was decreasing, and the value of the derivative is negative. So these rules do check out. Okay. For another example, let's find where this function is increasing and decreasing. Now, we don't have a graph of this function, but remember, for increasing, we can look for x values where the derivative of this function is positive. And to know where it's decreasing, we can look for x values where this derivative is negative. So, of course, the derivative of this function is a polynomial, since f is a polynomial. So it looks like it's minus x squared plus 2x plus 3. Okay. And to know where a function is positive and negative, well, really you need to know, first of all, where is it 0 and where is it undefined. Right? Really, we're trying to solve the inequality where this function is greater than 0. So to solve an inequality like this, first figure out where it's equal to 0. So minus x squared plus 2x plus 3 equals 0. And let's see, if we multiply everything by minus 1, then you might notice that this factors. This one's x minus 3 times x plus 1. So x equals 3, or x equals minus 1. Okay, so there are two places where this derivative is equal to 0. At x equals minus 1 and x equals 3. And I'll put solid dots on those just to indicate that f prime is actually 0 at those spots, as opposed to being undefined. Okay. So what we're going to do is, right, we need to know on each of these three, you see these points that we found, they break the real number line up into these chunks. And on each piece, the derivative has to be either positive or negative. It can't change from positive to negative inside of these chunks. The only way a function can change from positive to negative is if it goes through 0, or if it jumps across 0, at which point there will be some kind of discontinuity. Well, this function doesn't have any discontinuities, and this function, the derivative, doesn't have any discontinuities, and the only places where it crosses 0, where it actually goes through the value 0, are these zeros that we found. So that means in between on these intervals, it can't change sign. So on each interval, it is either always positive on that interval or always negative on that interval. Well, how to know on each interval which one it is, positive or negative? One nice way to figure out if it's positive or negative on each interval is just to pick any old number that's in that interval. Over here, maybe we could pick -2, and just plug it into this function, f prime. If we just evaluate f prime of -2, what we get is, let's see, -2 squared is 4, so -4 minus another 4 is -8 plus 3 is -5, so that's less than 0. So in other words, it's negative. So since f prime is negative at this value -2, it has to be negative on this whole interval to the left. So negative over here. All right, well now we can do the same thing for the interval from -1 to 3. 0 would be a nice point. F of 0 is 3. Sorry, f of 0 is 3. That's positive. So from -1 to 3, f prime has to be positive. Now from 3 onwards, we could plug in, I don't know, how about 4? Let's see, -4 squared, that's -16, plus 8 is -8, plus 3 is -5. So f prime of, oh, this should be prime here. F prime of 4 was negative. So negative like this. Now we know, what this chart tells us, I call this thing a sign chart. This chart is just a record of where this function, f prime, is positive and where it's negative. But remember, when f prime is positive, f itself is increasing. And where f prime is negative, f itself is decreasing. So that's here and here. So you can see this sign chart for f prime actually lets us just read off where f is increasing and decreasing. It's increasing from -1 to 3. That's from here to here, where f prime is positive. And f, so that's where f is increasing. And f is decreasing where f prime is negative. That's here and here. So that's from -infinity up to -1, together with union 3 up to infinity. All right, so there we go. Making a sign chart like this has let us figure out where the original function is increasing and where it's decreasing.